Let's continue looking at class notes from 7.2b. This is volume by Washer method. So example 2, find the volume of the solid created by revolving the function y equals x squared plus 1 bounded by the line y equals 2 revolved around the x-axis. So we have y equals x squared plus 1. This is going to be a parabola with a vertex at 0, 1. So we can graph that first. We also have the line y equals 2. And we see where the shaded region is going to be, kind of a semicircle. And we're going to be revolving this shaded region about the x-axis. All right. Now, notice the shaded region in relation to the axis of revolution. And we see that there's not only a gap, there's a hole. So think of this as the center of this object, of this ring. And if we take the shaded region and revolve it around this line, we're going to create a ring. And so we're going to have to find the area of the large circle and subtract the area of the small circle to create this ring-like shape. So we have to find two radius. We have to find big R and little r. So starting on the axis of revolution, we're going to be drawing big radius, and we're going to be extending this to the further function, further graph, or further curve. So this is going to extend to this line y equals 2. That would be big R. And little r, we're going to be taking, starting on the axis of revolution and extending to the inner curve, the closer curve. And once you have your big R and little r, you should be able to compare their length, and it should be able to tell which one is going to be the longer one. So big R should always be the longer length, and little r will be the shorter length. So if we want to find big R, because the axis is horizontal, this forces us to have to draw a vertical radius. So we know this is going to be using the top minus bottom formula, meaning that everything that we're having to plug in will be in terms of x. So to find big R, we locate the top of the radius, and we determine where the top of the radius is, which function the top of the radius is touching. So it's right on the y equals 2, so that will be the top function. And the bottom function will be the bottom of the radius, which will be at 0. So 2 minus 0 is 2. This will be the big R. Okay. Little r, we look at the small radius. We look at the top of the radius, and we see that it is on the curve x squared plus 1. Okay. And then we look at the bottom of the radius, and we see that it is on the axis. So x squared plus 1 minus 0. Okay, which gives us little r of x squared plus 1. Okay. Something else that we need are the bounds. Okay. We are stacking these vertical rings from this point all the way to this point. Everything has to be in terms of x, so we need to look for the x values, meaning that we need to set this curve equal to the line y equals 2. So when we do that, x squared plus 1 is equal to 2. We solve for x squared equals to 1. Then we can solve for x, so x is equal to plus or minus 1. So now our volume formula is essentially pi big R squared minus pi little r squared. We only need to write pi out once, but from our lower bound being -1, our upper bound being 1, big R squared minus little r squared. Essentially, we're taking the area of the big circle and subtracting the little circle away from it. Okay. When we expand, we can get 4 minus x to the 4th minus 2x squared minus 1 between -1 and 1. So we can either plug all this in the calculator, or you can go through power rule, plug in upper and lower bound. Either way, you're going to get 64 over 15, and we want to make sure we include the pi cubic units. Okay, let's look at example 3. Example 3 says, find the volume of the solid created by revolving the function y equals x squared plus 1, bounded by the line y equals 2, and the y-axis about the line x equals 4. So now this is going to be a vertical line, x equals 4. The additional restriction is that this shaded region is in the first quadrant, in quadrant 1. So we have the parabola y equals x squared plus 1. We have the line y equals 2. Initially, we have the same shaded region as example 2, but the restriction is that the shaded region is only in the first quadrant. So we have our shaded region, kind of a quarter circle, and we have our vertical line x equals 4. So think of this as the center of this object, and we're taking the shaded region, we're revolving it around this line x equals 4. Okay, next thing we have to draw our, look at the shaded region in relation to the axis. We see that there's not only a gap, there's a complete hole, so we have to, this will be using the washer method, meaning we have to find big radius and little radius. So we start on the axis, we always start on the axis, and we draw to the further curve function or graph. In this case, we're going to extend all the way to the y-axis. Okay. Little r, we're going to start on the axis of revolution, and we're going to extend to the inner curve, the closer function. In this case, this will be the x squared plus 1. Okay. We have to make an additional adjustment because we're using horizontal rectangles, horizontal radius, meaning that everything that we plug in have to be in terms of y. And if we do that, we're going to have to adjust our equation y equals x squared plus 1 and solve for x. So if we solve for x, first off we get x squared equals y minus 1. Take the square root of both sides, so x equals root y minus 1. So this curve can be represented as x equals square root of y minus 1. Okay, so we look at big radius, which is the longer length. Look at the right endpoint. It is right on x equals 4. So 4 minus, look at the left endpoint, which is at 0. So we get 4 minus 0, which is 4. Okay, we look at the small radius. The right endpoint is at 4. The left endpoint is on the root y minus 1. So small radius is simply right minus left, or 4 minus root y minus 1. Okay. Now, we have to now look at and find the lower and upper bound in terms of y. So if you look at this graph, the lowest y value that you see is going to be y equals 1. The highest y value of the shaded region is, because of this horizontal line, y equals 2. So then our bounds will be from 1 to 2, big R squared minus little r squared. Okay. And then we simply plug this in our calculator. This will give us a decimal value of 4.833, and we include the pi and we say cubic units. Okay, example 4. Find the volume of the solid created by the enclosed region of y equals x squared and y equals square root of x, revolving about the line x equals 2. So here's our shaded region. We have the vertical line being the axis of revolution. So if we revolve this about this line, it's going to create a kind of a lampshade kind of a figure. And we start on the axis of revolution. This is the center of our graph. We're going to extend to the further curve, in this case x equals y squared. And then starting on the axis of revolution, we're going to extend to the inner curve, the closer curve, which in this case is the y equals, actually this is initially y equals square root of x, and then the inner curve is the y equals x squared. However, we also need to adjust our equation because we're doing right minus left, so we have to rewrite our equation in terms of x equals. So x equals root y will represent the inner curve. X equals y squared, which is coming from y equals square root of x, will represent the outer curve. Okay. everything is in relation to this axis to determine which one is the outer curve and which one is the inner curve. Okay, so now we can find our big R, which is right minus left. So the right endpoint is at x equals 2, so that's going to be our right endpoint, minus the left endpoint is at y squared, so we have 2 minus y squared, that'll be big R. Okay, little r, we look at the right endpoint, which is at 2, we look at the left endpoint, which is at root y, so we get 2 minus root y. And this graph already tells us the bounds, because we see the lowest y value being 0, the highest y value being 1. However, if this is not given to you, we would have to set these two equations equal to each other, set root y equal to y squared, and if we solve for y, we're going to get 0 and 1. So our bounds being 0 and 1, we simply plug into our formula, big R squared minus little r squared. So remember, there's always this portion of area of big circle minus area of little circle. So big R squared is 2 minus y squared, quantity squared, minus little r squared, 2 minus root y, quantity squared. Okay, make sure that you're including the squared as part of your formula, and when you plug in your calculator, you'll get 1.033. Don't forget the pi, cubic units.